Now that we've talked about what population genetics is all about, let's talk about how we look at it. There are a couple different ways to look at population genetics manually, but why? There's a lot of numbers. It's kind of complicated looking at all these different things. So nowadays, we tend to use simulators, especially since we have the internet, to help us look at all of these things. So let's talk about a couple simple population genetic models and what we do. First, we simplify our problem a lot. We tend to only look at a single allele over time because that's a lot simpler than modeling all of the things that are going on in our body with, you know, tens of thousands of genes. We also usually assume a biallelic model. So we're assuming there are only two alleles, and that simplifies things a lot. Certainly, there are a lot more alleles for pretty much every locus that we're talking about, but this allows us to have a much simpler mathematical model. We also have a couple of conventions. Capital letters mean dominant alleles, and lowercase letters mean recessive. So certainly this is a very simplified situation, but this is a good way for us to start to get familiar with what's going on, so we can start to see how different forces of evolution operate. So here is an output from one of my favorite population genetic simulators online. And here I just use the default parameters. The default parameters generally have no forces of evolution operating, though for this one it does have genetic drift operating. That's how you can see the, kind of those squiggly lines there. Most generators will start off at a frequency of 0.5, so even between your two alleles. Generation is on the bottom, but really that's time. And you might notice we have our purple line up at the top. It goes to a frequency of 1 or 100, depending on how you're talking about it. And that is fixation. That allele is fixed, and it is the only allele present in this population. You also see this orange line here. It has the opposite thing happen. It goes to a frequency of 0. We call that being a loss or being lost. That allele is no longer present in the population, and the other allele has gone to fixation. If we only have a system where that we're talking about two alleles, if one is lost, the other goes to fixation and vice versa. Here is a different generator. So a very similar idea, but you might notice it just looks a little bit different. This one happens to have the parameters up at the top, so I was easily able to show them to you. And of course, we have the same frequency measure, so we have a couple populations go to fixation, and of course, a couple populations going to a loss here. But what's cool about these different simulators is they allow you to modify your parameters. So you can modify parameters about population size, migration, mutation, and selection. All of these tie directly into the different forces of evolution. So, do you know what would modifying each of these parameters do, and what would that mean for evolution? A great way is always make sure to read the directions and the help when you're trying to figure out how to use these different simulators. So, how do you use a population genetics simulator?